Hello and welcome to the Science for Sleepy. Tonight the lab lights are low, a glass bulb hums faintly on the edge of your desk, casting warm, amber shadows across an ocean of notebooks. The air smells faintly of ozone and old paper, and somewhere in the corner, a pendulum swings with the rhythm of a heartbeat. Our sleepy physicist sits motionless, chin resting on folded arms, halfway between awareness and slumber. The last thought before sleep, a question so gentle it barely stirs the silence. Why does light move at the speed it does? And why can nothing ever go faster? If you're enjoying this quiet journey through curiosity and time, consider subscribing. There's always more to explore, gently. We'd love to know your location and time zone in the comments. Somewhere far above the roof of this laboratory, the stars whisper their own old questions in the cold dark. But here, down in the pool of desk light, a candle flickers. A real candle. It's part of an experiment, or maybe just an excuse for warmth. A single flame. It dances, and in that dance centuries of curiosity sway with it. Imagine that tiny flame in a vacuum. No air, no wind, just pure darkness and that golden flare of heat, flaring and collapsing with quiet determination. The moment it lights, photons leap from the wick, streams of energy flying away in every direction at nearly 300,000 kilometers per second. That's fast, staggeringly fast, and yet perfectly still in its own way. You might wonder, how do we even know how fast light moves? Why that number? Why not something faster or slower? And why does it matter so deeply that it's become the universal ceiling for speed itself? The candle's light touches the far wall. If you could see at infinite resolution, you'd catch the moment those photons arrived. Not instantly, but with absolute precision. That journey across the room, though so quick we can't perceive it, is a tiny pilgrimage. And if you scale that up, from the candle to the moon, from Earth to the sun, from stars to galaxies, the rules still hold. Always the same pace, never faster. This flame isn't just light, it's time, movement, boundary. You realize now, every beam of light is a messenger, and every message is shaped by the speed it must obey. Centuries ago, people thought light must be instantaneous. How could it not be? We see lightning and thunder arrives later, but surely the light happens in the moment, doesn't it? But the sleepy physicist knows better. They dream of men with lanterns on distant hillsides. Galileo laughing softly in the dusk, trying to measure delay with crude shutters and quick hands, and failing. Light, it seemed, was either infinitely fast, or just too fast to catch with the tools they had. Still, the question burned. Could light actually have a speed? And if so, how does the universe know to respect it? The candle dies down slightly. You imagine yourself becoming smaller, drifting closer to the wick, floating among the particles leaping from the flame. At this scale, light feels like a waterfall of photons, tiny, massless bundles that don't accelerate. They're born at full speed. They don't need time to gather momentum. The moment they exist, they're moving. Always the same speed, always forward. Not forward in space, but forward in causality. Light doesn't just move, it connects moments. It defines what can happen and when. In that way, light sets the clock of the cosmos. In the laboratory, the physicist dreams a little deeper. Books surround them, some ancient, some filled with math so dense it looks like art. On the chalkboard, a faint diagram glows in the candlelight. Circles and lines, light cones. You might not know what those are yet, but you will. They will return, quietly, as we go on. For now, the flame sways again, and in its glow, We drift gently into a time when people first began to suspect that speed, even the speed of light, might not be an absolute, that perhaps even light had to answer to nature. But if so, then what enforced this law? What told light, you may go this fast and no faster? That question hangs in the dark like breath on cold glass. The physicists shift slightly, murmuring in sleep, their mind deep inside a labyrinth of possibility. And just for a moment, so are we. Outside the window, darkness stretches without edge. No moon tonight, just an endless night sky, the kind that makes you feel the depth of space pressing gently on the rooftop tiles. Inside, the candle has gone out, but the light remains in memory, in afterglow. We chase it now, not to catch it, but to understand what it leaves behind. We're not the first to chase light. For thousands of years, people wondered, what is light really? A substance? A current? A spirit? But the question that touches the edges of sleep tonight is simpler, more childlike, more eternal. Can anything move faster than light? Close your eyes for a moment and imagine you're out in a perfect vacuum, drifting silently in the blackest space. There's nothing around you, not a star, not a planet, no noise, no motion, just the faint trace of your own breath inside the helmet of a dreamt-up suit, and then a beam of light, a spark, far ahead. It appears in the distance and begins moving toward you, not gradually, not like a car or a train that needs to gather speed. It's instant, unapologetic, a full force of motion at the moment of birth. Light doesn't ease in, it arrives. You try to catch it with your eyes, but it's already gone past. And no matter how fast you try to imagine yourself going, it always stays ahead. A constant. Not the fastest we've measured, but the fastest that can be. This is the part that feels like a riddle wrapped in silk. The speed of light isn't just a measurement, it's a boundary, a wall of the universe's own making. You can get close, but you can never cross. Why? Because the faster something with mass moves, the more energy it takes to keep going faster. A little faster, that's fine. A lot faster, harder, near light speed, incredibly hard. But to reach the speed of light, you would need infinite energy, and to go faster than that, well, energy stops being meaningful in the way we understand. The universe simply refuses to compute. Like trying to divide by 0, it's not that you'll get a weird number, it's that the math collapses. The law breaks not because it's cruel, but because it's built into the logic of reality. Back in the lab, the sleepy physicist is now turning in their chair. The chalkboard glows a bit brighter in your imagination. You can see faint equations behind the light cones, symbols for energy, mass, velocity. They're whispering a truth. The closer you get to the speed of light, the heavier you become. Not metaphorically, literally. Mass increases. Your spaceship becomes more and more difficult to push. It resists. And this is not because of friction or gravity, it's because of the nature of speed itself. The universe is pulling back on your ambition, tightening the leash. You dream now of 2 racing beams. One is a beam of light, pure, weightless, and free. The other is a spaceship designed by the most brilliant engineers of a distant civilization. It begins to catch up, accelerating past. Stars pushing harder and harder, burning unimaginable fuel. But no matter how close it gets to light speed, it never quite gets there. 1,000th away, then 1,000,000th, then 1,000,000,000th. It keeps trying. But the light always stays a step ahead. Even if this dream ship could somehow go faster, something strange would happen. Cause and effect would become twisted. The ship might arrive at a destination before it left. Messages could be sent back in time. Time itself would unravel like a loose thread in a dark room. And so the universe seems to say, no, not out of cruelty, but out of consistency. This is what makes light sacred to physicists. It's not just fast, it's the seam in the fabric of reality. The line that says, here is what's possible, and beyond that line lies contradiction. You may wonder, if nothing can go faster than light, how do we ever reach distant galaxies? How do we dream of deep space at all? But the universe has loopholes. We'll find them in time. But tonight, as your breathing slows, think of darkness not as an absence, but as a field of potential. Darkness is not empty. It's waiting for light to arrive. The physicist drifts again, notebook open on their chest. A small doodle rests on the final page. A tiny figure running, holding a lantern, chasing the stars. You smile softly in the quiet, because you understand now, light does not simply move fast, it defines motion itself. You turn your attention inward, where another kind of light glows, the steady flicker of your own awareness. And in this space, you move as fast as thought. Faster than thought. Stillness in motion. A mind in orbit around the unknowable. We're not chasing light. We're listening to what it has always been trying to tell us. Wind rustles through tall grass. You're standing on a hill in the Italian countryside. It's twilight. Dusky, golden, and quiet. The sun has dipped below the horizon, and the last pale beams of day stretch out across the fields. In the distance, two figures stand with lanterns, flickering dots in the dark. They're waiting. You're watching Galileo, not the famous marble statue version with stern eyes and grandeur. This is the real one, alive, curious, mischievous. He's young. His beard is still dark and he's laughing. The wind is blowing and the shutters on his lantern rattle. This is science in its purest form, messy, uncertain, human. Galileo is trying to do something no one has truly done before, measure the speed of light. His method is charming in its simplicity. He opens a lantern and waits for his partner, standing far away to see the light and open theirs in return. He times the delay, and yet, it doesn't work. Not really. The delay is too small. Human reflexes are too slow. Light is too fast. They try again. The laugh echoes again. Galileo isn't frustrated. He's delighted. Even his failure, there's something profound. The idea that light has a speed, something finite, something that could be measured, was new, bold, almost blasphemous. But there's something beautiful here too. Not the failure, but the try. The image of two people, lanterns in hand, trying to catch the delay between a spark and a blink. We often think of science as certainty, but in this sleepy evening world it begins with wonder. Now imagine the air between them, full of moving light, yes, but also full of expectation, of anticipation, of the gap between what we sense and what is truly happening. Centuries would pass before anyone truly measured the speed of light. But Galileo started something. He changed the question. Light was no longer instantaneous by assumption. It was a puzzle, a thread to follow. In dreams, we sometimes float backward in time. Through fog and candlelight, we drift toward other attempts. Ola Roma, watching the moons of Jupiter vanish and reappear. Fizeau, spinning mirrors and racing light against running water. Michelson, refining it all to exquisite precision. Each one, in their own century, listened more closely to what light had been whispering all along. Not just how fast it moved, but that it moved at all. The laboratory is still. Our sleepy physicist has left the chair and lies curled on a worn couch, surrounded by scattered diagrams. One sheet has fallen to the floor. On it is a simple sketch. 2 lanterns, 2 hills, a dotted line of light between them, a child's drawing, and yet you find yourself wondering, why did Galileo's idea matter? Why return to it here as sleep wraps tighter around your limbs? Because this is where the pursuit began, not with equations or labs, but with eyes straining across distance, with time measured not in nanoseconds but in heartbeats, and with the realization that light, though invisible as it moves, is not instant. It travels, and everything that travels can be traced. Tonight, you feel the wind from that hill still moving through you, a whisper from the past, the distant glow of 2 lanterns across a field where something simple and profound is being attempted. Galileo doesn't need to succeed. He already has. He's proven, gently, that not everything happens at once, that there is a delay, however small, in how we come to know the world. And in that delay is space for thought, for curiosity, for science. You turn again toward the present, the couch, the notebook, the low hum of distant machines. But the hills remain behind your eyelids, soft and golden, eternal. You're not on a hill, and yet you are. You're waiting too for the light to arrive. Now we drift through a meadow, not of flowers or grass, but of equations and daydreams. You ride a bicycle. It hums softly beneath you, tires brushing along a country road that winds through fields stitched with golden wheat. The sky above is blue and endless. There are no cars, no noise, only the steady rhythm of pedalling and the whisper of the wind. You are not alone. A thought rides beside you, a peculiar, persistent thought. What if you could ride alongside a beam of light? What would you see? What would light look like if you could catch it? This is not your question. It belonged to a quiet Swiss patent clerk in the late 1800s, a man not yet famous, not yet the Einstein we would come to know. He asked it in solitude, peddling his own way to genius, and it was not a simple thought, it was an unsettling one, because if you could match the speed of light, something very strange should happen. The light wave in front of you should stop moving. It should just freeze there, like a standing ripple. But the laws of electromagnetism, Maxwell's beautiful equations, didn't allow for that. A standing light wave was nonsense. It broke the math. So what then? If the equations were right, and they were, then maybe you couldn't catch light. Not ever, no matter how fast you went. The bicycle slows. You feel time stretch slightly. Your surroundings seem to blur, but not because you're moving faster, because something else is shifting, something deeper. Einstein realized that the only way to make the math and the dream agree was to throw out an old belief, that time and space were absolute, that everyone experienced the same now. They don't. Once you accept that the speed of light is constant, not just usually, not just most of the time, but always, you're forced to change the way you understand everything. Time, space, motion, cause. Everything becomes relative. Not false, not broken, but relative to how fast you're going and where you are. The sleepy physicist murmurs something unintelligible from the couch, caught in a deepening slumber. Perhaps they too are dreaming of that impossible bicycle ride. That moment when Einstein, drifting beside a beam of light in his mind, realized something that would change the course of science forever. It is gentle, this shift, not dramatic. You barely feel it, like a train easing into motion or a boat drifting on a tide. But it is irreversible. Imagine now that your bicycle is accelerating. Faster, then faster still. You pass trees, then shadows, then stars. Everything around you begins to shift, not just blur, but contract. The space in front of you flattens, time slows. You're not just moving quickly through space, you're reshaping how space and time behave around you, and yet the light beam ahead still races on, unreachable, untouchable, constant. This is the seed of what will become special relativity. Not a theory about light, really, but about everything else because of light. About how the universe rearranges itself to keep light speed sacred. You pedal slower now, the fields return, the sun lowers. That light beam, always just ahead, dissolves into the horizon. You're left with a quiet understanding. You don't chase light to catch it. You chase it to find out what it reveals in your failure. The physicist's chalkboard glows faintly in the candle's afterglow. A new sketch, a bicycle, a light wave, and two curving axes labelled time and space. They bend around each other like lovers, inseparable. And beneath it, a single line scribbled hastily. If you want to keep the speed of light constant, space and time must give way. The bike ride ends not with a finish line, but with a deep breath, a knowing smile, a whispered surrender to the laws of a world more flexible, more strange, more beautiful than we once believed. You are not tired, you are in motion. But the motion is inward now, toward a truth that flickers and glows just beyond the reach of thought. The air is different here, colder, still, as if even the universe is holding its breath. You step softly into a room without walls suspended in darkness. Floating before you is a sign, not made of matter, but of understanding. It reads, "Speed limit enforced by the universe," and it means exactly what it says. The speed of light is not just fast, it is final, a boundary not made of fences or laws, but of logic itself. Nothing, not a spaceship, not a thought, not a dream, can move faster. It isn't a rule that can be broken under special circumstances. It isn't a limit we just haven't yet overcome. It is the foundation on which space and time are built. Try to go faster, and the universe quietly changes the rules beneath your feet to stop you. This is difficult to feel in everyday life. Here on Earth, nothing ever comes close to light speed. The fastest jet, the quickest bullet, even the most advanced spacecraft, all of them crawl when compared to light, a snail beside a beam. But in the heart of the equations, in the bones of the cosmos, the limit is always there. A cap, an asymptote, a silent ceiling that no one, nothing, ever touches. You drift now through the thought, deeper. You arrive in a laboratory with no gravity, no temperature, just ideas floating in silence. Here, time and space are coordinates, fluid, stretchable, obedient to one rule. Light must always move at 299,792,458 meters per second. Nothing faster. Even if you start moving toward the light, away from it, sideways across its path, the speed of the light beam remains unchanged. The universe does something elegant. It bends time and space to make the math stay true. To keep the speed of light constant, everything else must flex. You are walking now, gently, along a path made of starlight. With each step you remember the strange consequence. As you move faster, time begins to slow for you, and space begins to contract. Your world changes to protect the sanctity of the light speed. It's not just a number, it's a principle. Imagine this: two spaceships, moving away from each other at enormous speeds. Both switch on a flashlight. Each observer sees their own light beam travelling at the exact same speed. How can that be? Shouldn't the speeds combine or subtract like cars on a road? But no. The universe doesn't add or subtract velocities that way, not with light. It preserves its constancy by altering perception itself. This is where the laws of physics begin to whisper rather than shout. Not in declarations, but in quiet accommodations. They say, if light is to remain unchanged, you must give up your illusion of time, of simultaneity, of shared now. And so we do. The sleepy physicist stirs again. Their hand reaches out in their sleep, sketching an imaginary circle in the air. You see the echo of that motion, a ripple in space-time. Because this isn't just about speed, it's about the nature of reality. At the speed of light, time stops, not slows, stops. From the perspective of a photon, there is no journey, no passage. It is emitted and absorbed, two ends of an event that, for the photon, is the same moment. This is what we mean when we say, nothing can go faster than light. It's not a speed trap. It's not a dare. It's the edge of meaning. Beyond that point, time itself begins to fold and break. You hover at that edge now, gently, in awe. The physicist's chalkboard shows a line, space on one axis, time on another, a diagonal slash across both. That's light's path, the only perfect diagonal. Anything else? It curves, bends, struggles. Light is the limit, the benchmark, the law. But within that law lies freedom, a framework, a stage on which everything, every event, every cause, every dream can play out. To break the speed of light is to step off the stage entirely, and so we don't. We remain here, inside the frame, watching the speed limit sign, not with frustration, but with reverence. You lie back now, eyes closed, breath slow, and in the hush between your thoughts, you feel it. The limit is not a prison, it is a shape, the shape of everything that is. Imagine a hallway made of mirrors. It stretches infinitely in both directions, lined with perfect reflections of clocks, grandfather clocks, digital clocks, pocket watches, all ticking softly in a rhythm you can almost hear, like distant footsteps in a dream. The hands move in slow unison, but then one begins to hesitate, and another, and another. You step deeper into the hallway. With every pace forward, time seems to stretch, not figuratively, literally. We're entering the strange world where speed distorts time, where moving faster doesn't just get you there sooner, it changes the very experience of time itself. This is time dilation, not a trick, not a glitch, a law, a real, measurable effect of getting closer to the speed of light. A spaceship zipping by at a fraction of light speed might contain a traveller. For them, only a few minutes pass. For those left behind, years roll by. The faster you move, the slower your clock ticks, from the perspective of the still observer. But for the traveller, time feels normal. That's the mystery. You don't feel time slowing. You simply carry it with you, a private universe ticking at your side. The sleepy physicist knows this. Somewhere in the folds of their blanket lies a worn journal filled with sketches of watches floating in space, trails of motion bending the numerals. One page has a simple note: speed warps experience. Time is not absolute. We live in curved rhythms. You linger in this mirror hall of clocks, drifting past each timepiece as it slows. At first, just a little, then more, then almost not at all. The ticking becomes imperceptible. At near light speed, the hands barely move, and if you somehow reached light speed, though we know you can't, time would freeze entirely. From light's perspective, there is no time between its beginning and end. It just is. This is hard to grasp. It makes the air feel thinner, the floor less solid, but it's not science fiction. It's already been measured. Satellites in orbit around Earth experience time differently than we do on the surface. GPS systems must correct for this subtle warping every second, and that's just low speed compared to light. Now imagine a twin, a thought experiment long whispered among physicists. One twin stays on Earth, the other boards a spaceship and travels close to light speed for what seems like a year. When they return, they've aged a year. The sibling on Earth? Decades older. They were born together, but speed has pulled their timelines apart, and still, no laws were broken. Time itself simply flows differently depending on your motion. You glance up. The hallway begins to shimmer. The clocks dissolve into stars. The universe itself is a clock, an expanding, ticking field of possibility. But not every observer sees it the same way. Motion bends the rhythm, and so, every path through space-time is personal, subjective, valid. The sleepy physicist stirs. They are dreaming now of a light beam and a mirror, bouncing back and forth inside a glass tube on a moving train. The same beam, bouncing between two mirrors, takes longer from the outside perspective than from the person on the train. Why? Because the light must travel diagonally to keep up with the moving tube. More distance equals more time, but the speed of light stays the same, so it's not the light that changes, it's the clock. You breathe slowly. Not everything slows with speed. Only time, only duration, and the closer you get to light speed, the more dramatic that stretch becomes. In this dream, you are the traveller now, watching galaxies rush past like droplets on glass. Your ship hums, your heart beats, your clock ticks, and all feels still. But outside, aeons bloom and fade, and when you return, the world you knew is gone. All because you dared to get close to the boundary that light protects. You open your eyes, the hallway is gone, the stars remain, they always do. And somewhere in their ancient glow is the quiet knowledge. To move faster is to drift farther from the familiar shape of time. But the light remains constant. It watches over all of us. No matter how fast we go. You're floating now, not forward, not backward, but inward. The stars above you dissolve into equations. The floor beneath your thoughts becomes soft, warping gently under the weight of speed. Ahead of you, a spacecraft, silver and silent, gliding just beneath the speed of light. You don't see engines or fire, only the shimmer of space warping around it, like heat above desert sand. The ship isn't burning fuel now, it's fighting nature. Because as it gets faster, something strange is happening. It's shrinking, not from damage, not from fear, but from the quiet grip of special relativity. This is length contraction, another dreamlike consequence of approaching the speed of light. From the point of view of an outside observer, the spacecraft begins to compress in the direction of travel. If you are standing still, watching the ship race past, it appears squashed, shorter than it should be. A ship that once stretched the length of a stadium now barely spans a hallway. But on board, the crew feels no change. The walls still stand. The floor is still firm beneath their boots. Their rulers, clocks, pulses, they behave normally. It is only you, the still observer, who sees the ship shrink. And why? Because the universe bends to keep light speed unshaken. The faster you go, the more the universe rearranges itself. Time slows, space compresses, and all of it happens not to punish you, but to preserve a deeper symmetry. You drift now alongside the ship. You look in through a translucent wall and see a traveller sitting in quiet contemplation. They are moving so fast that to them, the stars appear compressed, streaked forward by motion. You watch as a cup of tea floats beside their hand. From your still frame, it seems frozen. From theirs, time is normal. The physicist, half asleep on the couch, has scribbled a diagram showing both perspectives, one where the ship contracts, another where the universe around it distorts. Both are true. Each depends on motion. And so, we are forced to give up the idea that there is one objective way to see space and time. There are many, each shaped by how fast you are moving, each governed by one unbreakable rule: light always moves the same speed. So when the ship approaches the speed of light, it shrinks from your view. Its clock ticks slower. Its mass increases. All signs of resistance. Not from any barrier, but from the fabric of reality reshaping itself to protect consistency. There's feeling here, gentle but immense, of humility. We're not at the center. We do not get to define how time flows or how big things are. We only get to experience it from where we stand and where we move. Back on Earth, a telescope stares upward. It receives light from a star that died long ago. That light took thousands of years to get here. But for the photons, no time passed at all. The journey was instantaneous, from their point of view. No clocks, no distances, only emission and arrival. Two ends of a moment that for them was one. And yet for us that star is ancient. We look at it through layers of space and time that feel thick as velvet. The physicist dreams of this duality, of something being far and close at once, old and immediate. You float back to the shrinking spaceship. It moves faster now, closer to the limit. The stars curve around it. The colors shift, blues sharpening in front, red stretching behind. This is not magic. This is relativity. A world of shifting frames, changing sizes, altered flows of time, all to keep the speed of light unshaken. And still the ship cannot cross that final barrier, because to do so it would need infinite energy. Its mass would become infinite. Its time would halt. And the universe in its quiet firmness will not allow it. And so the ship travels fast, but never too fast. And we, who watch it shrink and slow and blur, are reminded that speed is not just motion, it is transformation. To approach the speed of light is not to break through, but to dissolve gently into the edge of knowable experience. You drift downward now, as if falling through velvet fog. The silence deepens, becomes heavier, more absolute. The stars fade away. In their place, walls of polished stone form around you. Cool, precise, metallic. You're underground, deep beneath the surface of the earth. This is no cave. It is a tunnel. Endless, circular, humming faintly. You're inside a particle accelerator. Here, beneath the noise of the world, humans have built rings where particles race at speeds close to light itself. Electrons, protons, tiny things with tiny mass, hurtling through vast magnetic corridors in loops thousands of meters long. They do not glow, they do not scream, but they push, and they strain, and they try. And yet, they never quite reach light speed. This is where nature shows her quiet strength. No matter how much energy we pour into these particles, no matter how strong the magnetic push, or how sophisticated the machine, the result is always the same. The particles grow heavier, more resistant, and their speed edges ever closer, but never touches the final line. This is not limitation. This is reality. Reminding us that the rules are not negotiable. The sleepy physicist, even in dreams, understands this. They once spent months watching collision data stream across a screen. Each event, a flash of possibility, a particle, racing as close to light speed as any object with mass could ever go, and yet still slower. You walk the edge of this circular tunnel now. Time feels warped here, like the air is folding in loops with every circuit the particles complete. They make tens of thousands of laps each second. From our view, their clocks are crawling. From their perspective, their path is short, their experience rapid. Again, we return to the core truth. Reality adjusts itself to protect the speed of light. Particles gain energy, but their velocity creeps forward more and more slowly. At 99% light speed, they behave one way. At 99.9%, another. And as they near 99.9999%, they become heavier, as if dragging the weight of their own future behind them. It is as if the universe whispers, "You can try, but you will never break through." And these particles, silent, mindless, obey. But there is awe in their struggle, because in every orbit, every near light speed revolution, they confirm the same thing. The barrier holds. Always. You close your eyes. Imagine being one of them, a proton, riding the magnetic winds of the collider. To you, the tunnel is barely a meter long. Time moves strangely. The outside world barely ages while you complete your race. Your existence becomes narrowed to a sliver of now. You are a flash of purpose, repeating a loop that, from the outside, takes microseconds, and from within feels eternal. Then, the collision. Two particles meet at impossible speeds. Their energies convert into matter. New particles, new dances. We study these flashes not to make something faster than light, but to better understand why nothing can be. Every spin, every collision is a question whispered into the void, and every result is the same quiet answer. No, not faster, never faster. The physicist, half covered in a wool blanket, once visited such a place, touched the tunnel wall, felt the hum of the world's most precise question being asked again and again. What happens if we push just a little harder? And the universe replies, mass grows, time slows, space contracts, but the limit holds. You let yourself sink into this answer, not with frustration, but with peace. We are not meant to pass through this wall. We are meant to learn from it. Light does not rush. It does not boast. It simply defines the boundary. Quiet, unchanged. Even here, where particles scream through vacuum and magnets curve the paths of things we cannot see, the law is kept. And in keeping that law, the universe shows us its shape. You exhale. Deep underground, where particles chase the edge of possibility, you feel no noise. Only the faint rhythm of order, kept perfectly in place by something faster than nothing else can be. Somewhere between silence and spark, you find yourself inside a ripple. Not a place, not a room, but a rhythm. Here, there are no engines, no collisions, no mass, only waves and flickers, riding the seams of space. This is where light becomes not just fast, but strange. You're standing in the middle of a beam, not beside it, not watching it, but within it. You feel no push, no warmth, and yet you know something is moving. Something is dancing. This is light. Not just a flash, but a phenomenon, and it is both a particle and a wave. The sleepy physicist has always loved this part. In their notebook, slipped open beside a cooling mug of tea, is a small sketch. A wavy line on one side, a dotted line on the other. Underneath, a single word, duality. Because light isn't either or, it is both and neither. When we try to measure it as a wave, it behaves like one, spreading, interfering, bending around corners. When we measure it as a particle, a photon, it shows up as tiny hits, individual impacts on detectors, like rain tapping on a roof, but never both at once. always what we choose to observe. It seems impossible, like a dream choosing how it appears based on what you expect. And yet, this is light's nature, always constant in speed, always flexible in form. You drift deeper now, inside the beam. You don't feel motion, but you know it's there. Because light never rests. It cannot. It has no mass. And massless things cannot slow down, cannot pause. They exist only in movement. That's what makes light unique. Not just fast, but utterly, fundamentally unstill. Everything else needs a push to get moving. Everything else slows down without it. But not light. Light is born in motion. And the moment a photon is created, inside a star, inside your lamp, even from the friction of your blanket, it races outward at full speed. Always. Everywhere. There is no photon at rest. There is no such thing as still light. Even in the vacuum of space, even in the cold dark between galaxies, light keeps moving, and it doesn't age. It doesn't experience time. A photon born in the earliest days of the universe, 13 billion years ago, is still racing through space, unchanged. From our point of view, it's ancient, but from its own perspective, it was just born. This is why light is more than a tool or a phenomenon. It is a message, a boundary, a kind of perfection. It shows us what it means to be without mass, to be untouched by the friction of time. You feel it now, the deep silence of being inside something that doesn't age, doesn't pause, doesn't doubt. In the lab, a prism sits on a shelf. Moonlight passes through it, splitting white into colour. A tiny rainbow spills across the wall, quiet and soft. Every colour travels at the same speed in a vacuum. Red, violet, blue. All beams of different frequency, same velocity. That's the miracle. That's the truth. No matter the colour, no matter the source, no matter the moment, light, always, moves, the same. You step out of the beam, you're weightless now, informed by it, and maybe a little more awake to the idea that constancy is not boring, it is profound. A photon travels the universe, unseen, silent, immune to time, and we catch it in our eyes, in our instruments, in our thoughts. It defines our days and carves our shadows. It reflects off oceans and fills our photographs. It is the measure of speed, not because it is fast, but because it is right. And for just a moment longer, we're allowed to witness what it means to be free of mass, free of resistance, free of everything but the motion itself. Above you, silence. Beneath you, silence. Before you now, something different. The vastness of space, a field of stars, and somewhere, among them, a photon begins its journey. It does not weigh anything. It doesn't have a size in the way we understand. It is pure energy, born without mass, and so it is bound to a unique fate, to travel at light speed always, no less, never more. We have followed light from candles and clocks, from mountain tops to underground tunnels, from dreamlike bicycles to shrinking ships. Now, we turn to the very core of the matter, or rather, the absence of matter, because what makes light so fast is not just that it's small, not that it's magical, it's that it's massless. This is the secret that mass hides from us. Mass resists motion. The more you have, the harder it is to move. A car takes more to push than a feather, a planet more than a pebble, but light needs no push. Because it has no mass, it does not resist acceleration, and so it never had to accelerate at all. From the moment of its birth, it moves at the only speed it can, the speed of light. There is no rest frame for a photon, no standing still. In the equation that defines motion, E equals mc squared, a photon's mass is 0, but its energy is not, because energy can exist without mass, just as a ripple can exist without a stone. You float now beside a newborn photon, freshly emitted from a distant star. It moves without effort, without friction, without pause. Time does not touch it. It moves through space, but space itself warps gently around it. 1 billion years pass from our view. But for the photon, there is no journey, just beginning and end. This is hard to grasp. It defies the way our bodies experience motion. But you're no longer only a body. You are an observer in this thoughtscape, and you are allowed, briefly, to feel what it means to be without mass. The sleepy physicist turns in their blanket, murmuring a formula in half-sleep. Their chalkboard bears a simple equation now. V equals C only when M equals 0. Nothing with mass can ever move at the speed of light. Because as speed increases, so does relativistic mass. Energy is needed in greater and greater quantities. Near the limit, the amount of energy required becomes infinite, but a photon never needed to be pushed. It was born moving. You open your mind wider. Electrons, protons, people, we all need fuel. We all grow heavier with motion. We all age as we move. But photons, they are passengers of the absolute, carriers of information, messengers of causality. From cosmic background radiation to the flicker of a match, every photon tells a story of motion unburdened. That is why nothing can go faster, because only the massless may even touch this speed, and we are not massless. We are built of substance, of resistance, of delay. Our journey through the universe is one of friction, of slowness, of process. But light is different. Light is finished the moment it begins. It shows us not just the fastest speed, but the only permitted speed for anything that wants to escape time, and yet even that freedom is a kind of chain. The photon has no rest, no perspective. It cannot stop to admire what it passes. It only moves, always. You drift now among these massless messengers, photons from stars, from fireflies, from screen pixels and lightning bolts, all of them flying, none of them aging, none of them slowing. You understand now why nothing can go faster, because to be faster, one would have to be even more massless than nothing, even more exempt from resistance than what already doesn't resist. But light leaves no room for that. It already owns the peak, the edge, the end of speed, and so the limit remains. Not because the universe is cruel, but because the math is kind, and in its kindness it gives light the gift of speed, and gives us the gift of wonder. You're standing on the edge of a mirror, not a glass one, but a mirror made of thought. On one side, your past, on the other, your future, and in between, this fragile moment, this now. But tonight, even now is uncertain, because as we press further into the mystery of light speed, we arrive at a strange paradox. A place where faster than light isn't just forbidden, it becomes destructive, not to matter, not to energy, but to logic. This is the dreamlike edge of causality. Here, we ask, what if something could go faster than light? Just as a thought experiment, a whisper of what if. Imagine sending a signal to a distant friend, but the signal moves faster than light. It reaches them almost instantly, before you even finish pressing the send button. They respond, and their reply, also faster than light, arrives before you ever sent the first message. You stare at your inbox, a reply to something you haven't written yet, and in that moment, cause and effect collapse. This is the danger, not of explosion, not of noise, but of reversal. Faster than light travel means messages could go backward in time. Events could loop. Paradoxes would bloom like impossible flowers. What if you told your past self not to send the message? What if they obeyed? Then the message never existed. But the reply did. But it shouldn't. But it does. Round and round. The sleepy physicist has scratched a circle onto a chalkboard. Inside it, faster than light. Backward in time. The equal sign is drawn gently, as if reluctant to admit its own truth. This isn't science fiction. It's embedded in the mathematics of special relativity. If you exceed the speed of light, even slightly, the timeline bends. Different observers would disagree about the order of events. One would say the explosion came first, another would say the scream came before it, and the deeper the speed violation, the greater the disagreement. Eventually you lose the ability to say what came first at all. The universe no longer agrees with itself, and so, light speed stands not just as a barrier of motion, but of meaning. It separates the realm where time moves forward from the realm where cause dissolves. You find yourself now standing between two clocks. One ticks forward, the other ticks back. The ticking is soft, almost inaudible, but terrifying in its implication. To go faster than light is to unravel time, and so we don't. Not because we lack technology, but because we need consistency. Our world is made of stories, and stories need order. First this, then that. A push, then a fall. A spark, then a flame. If then becomes flexible, if before and after blur, we lose the ability to understand. And so, the universe protects the boundary. With math, with causality, with silence. You reach out and try to touch the mirror again, but it wavers, uncertain. The edge of light is also the edge of what we can say with certainty. To cross it would be to fall into a place where the question, what happened, has no single answer. And perhaps that is the deepest reason light speed cannot be broken, not because of limits in energy, but because of limits in sense, because beyond that speed, truth begins to vanish, and so you retreat, not in fear, in reverence. Light does not just move quickly, it protects the arrow of time, it keeps the past behind us and the future ahead, and in doing so, it keeps us whole. You are standing on the surface of the moon. There is no wind here, no sound, only silence, stretching endlessly in every direction, broken by the occasional glint of sunlight off ancient metal. Before you, half buried in fine dust, stands something unexpected, a mirror. Not a smooth decorative one, but a panel of prisms, sharp, precise, and placed here by human hands decades ago. It's not for looking into, it's for sending light back. This mirror was left here during the Apollo missions, quiet, patient, waiting. And across the vast emptiness of space, scientists on Earth still aim lasers at it. They send beams of light toward the moon, tiny pulses that travel nearly 400,000 kilometers, bounce off the mirror, and return home. The round trip takes just over 2.5 seconds, not instant, not imaginary, measured, predictable, sacred. This is how we know the speed of light isn't just theory, it's real, it's measurable, it's as much a part of our universe as gravity or breath. And these moon mirrors, these lonely reflectors, are proof. Each pulse of light is a question, each return is an answer, and between the two, time, distance, limit. This experiment has been repeated thousands of times, always the same delay, always the same gentle reminder. Light travels at a fixed speed, even across the vacuum of space, even through nothing, from Earth to moon, and moon to Earth again. You picture the light as it moves, fast, yes, but not instantly. you begin to see the seconds stretch between the planet and its satellite. A delay, a heartbeat, a truth. The sleepy physicist once watched this experiment live, blinking through the glow of a monitor while sipping tea. A photon leaves Earth, travels to the moon, reflects, returns. 2.5 seconds. No variation, no surprise, only precision. The signal is not slowed by atmosphere, not rushed by urgency. It obeys the rule without question. And the beauty of it? This light, this tiny packet of energy, was never meant to tell time, but it does. It holds within its speed the scale of our solar system, the size of our world, the distance between longing and reunion. You imagine now sending a message, not to the moon, but to someone waiting far across space. They will not receive it instantly. They will wait, just as light waits, just as time waits. Even if your message is urgent, light will take its time, because it must. This delay becomes more than an inconvenience. It becomes an architecture. It defines communication. It defines presence. It defines now. Because there is no true now that spans all of space. Your now is local, defined by what light has reached you. The farther away something is, the older its image, the deeper its delay. You stare at the moon in this dream and realize, even the moon you see is a moment ago, and the stars, millions of years ago, and the galaxies, ancient histories, still arriving, because light takes time, even at its relentless speed. The universe you observe is not the universe as it is. It is the universe as it was, filtered through time, delivered by photons. You lie down in the moon dust. The mirror reflects nothing now, only black sky. But still it waits, to return whatever message we send. Not faster, not slower, just right. Because that's what light does. It does not rush, it does not guess, it arrives, always at the speed it must. You're surrounded by stars now, not in the sky above, but all around. They hang in the dark like lanterns in a vast eternal cathedral. But something's not quite right. Some of these stars are long gone. Their light still travelling, still arriving, still being seen. You begin to realise what we call the present is a patchwork of pasts. The closer an object is, the more recent its light. The farther away, the deeper its history. When you look into the night sky, you're not looking into space. You're looking into time. Each photon hitting your eyes has been on a journey, some for minutes, others for millions of years. They've crossed galaxies, passed by exploding stars, threaded through gravity's curves, just to arrive now, softly, without sound. And so the idea of now, this moment, this shared reality, crumbles gently in your hands. Because what is now if every part of space delivers its story on a different delay? There is no universal clock. There is no synchronized universe. Only a tangle of lights, arriving when they can. The sleepy physicist's journal falls open to a simple diagram. A triangle, labelled with 3 points. One for a distant star. One for Earth. One for the photon, en route. Beneath it, the present is not flat, it is layered. Imagine yourself now on a distant planet orbiting a faraway sun. Your now looks different. Your view of the cosmos is based on what light has reached you, not what is. On Earth, we believe we live in the present, but even the light bouncing off your friend's face takes time to reach your eyes. Not much, but not nothing. And if something moved faster than light, it would arrive before it was sent. It would destroy this delicate layering of past and present. This is the danger, again. Not just breaking a law, but breaking order. Light enforces time's hierarchy. It keeps the past behind, the future ahead, and the present as a sliver between the two. You walk slowly now through this starfield of memory, each one a ghost, each one real. This is why the speed of light matters. It is not about travel, it is about truth. If you could see everything instantly, there would be no mystery, no delay, no depth. But with light's gentle pace, the universe unfolds itself, gradually, elegantly, layer by layer. The further we look, the older the light. And yet it still finds us, still reaches us, still delivers its ancient whisper. The stars you see tonight may have died 1,000,000 years ago, but their light lives on, crossing time and space with one message. I was here. You pause in the dark. You feel the age of every beam touching your skin. You feel the patience of the cosmos, and suddenly, you do not mind the delay, because it means the universe is not a blur. It is a sequence, a story, and every photon is a word spoken long ago arriving right on time. There is fog all around you now, a silver mist clinging to your thoughts, curling through the corridors of understanding, and in this fog, something flickers, something strange, a whisper of possibility. You've heard of them before, tachyons, particles that, if they existed, would always move faster than light. Not sometimes, not almost, always faster. But there's a catch. To move faster than light, a particle cannot ever slow down enough to reach light speed. It would require infinite deceleration to even touch the barrier from the other side. And so tachyons, if they are real, are forever exiled from our part of the universe. Always beyond the line, always unreachable. They exist only in theory, in equations that accept the absurd and let it live for a while. The sleepy physicist has drawn one on the edge of their notebook, a spiraling arrow labelled V greater than C, no mass, no interaction, no detection, just a question. What would the universe be like if these existed? You drift now through this fog of theory, chasing the outline of something that may never be. Tachyons would not help us travel through space. They would help us break time. They arrive before they depart. They unthread causality. And still, they haunt the edges of physics, like mythological beasts, beautiful, terrifying, and probably imaginary. They appear in solutions to equations that don't care whether the answer makes sense, only that it fits. Mathematics doesn't fear paradox, but nature might. You imagine a world with tachyons, where information can be sent into the past, where the effect might precede the cause, where your decisions echo backward, rewriting your memories. It is not a world you can hold together. It slips through your fingers, flickering, untethered. This is why most physicists believe tachyons cannot exist. Not because they're slow, but because they are too fast for reality to stay real. The speed of light isn't just a limit on motion, it's a boundary around meaning, and tachyons with their defiance sit just beyond that boundary. They are like reflections that don't wait for you to move, like answers whispered before the question is spoken. Elegant in theory, impossible in practice. You walk further into the fog. The shadows of tachyons dance around you, but never settle. They are the dreams of a universe that might have been, not the one we live in. Still, you do not fear them. You respect their beauty, because they remind us the speed of light isn't just about what exists, it's about what can exist without contradiction. The sleepy physicist closes their journal. The page with the spiraling arrow is folded softly into silence, and you, stepping gently back from the edge of the impossible, carry with you a strange gratitude for the light that moves at the speed it does, for the laws that hold, for the threads that keep time moving forward. Tachyons may remain in the mist, but you remain in the rhythm, and the rhythm is everything. Now you are drifting through something vast but invisible. Not a space, not a thing, but a movement. The entire universe is stretching. At first you don't feel it. Your hands don't tremble. Your feet don't slide. But with every moment, space itself is expanding, quietly, constantly. This is cosmic inflation, not an explosion outward from a center, but the stretching of the fabric of space-time itself. And as the cosmos expands, something strange happens. Distant galaxies move away from us. Some of them, far enough, move away faster than the speed of light. But wait, didn't we say nothing can move faster than light? Yes, and that rule still holds, because these galaxies aren't moving through space. The space between us and them is growing. This is the difference, and it matters. The cosmic speed limit applies to objects travelling within space-time, but space-time itself? It has its own laws. You're now watching galaxies drift beyond the horizon, not a visual one, but a causal one. The cosmic event horizon. Beyond that line, the light they emit now will never reach us. Not in a billion years, not ever, because the universe expands too fast in those regions. The light tries to travel toward us, but the space it must cross is always growing faster than the light can bridge. It's not breaking the rules, it's obeying a deeper one. The sleepy physicist once described it in a lecture, barely awake. Space is not a river that carries boats. Space is the river itself, stretching the distance between shores. You imagine standing on one shore watching another fade, not because it's moving, but because the river is growing, and so galaxies slip beyond view, not gone, just unreachable. This is not frightening, it is peaceful, because it shows us that even the vastest things respect the speed of the light, not by stopping, but by working around it. The light from some galaxies still races toward us. We see their stories in telescopes, but others have crossed the boundary. Their light, now trapped behind the fabric's expansion, will never arrive. And this too is part of why nothing can move faster than light. Because even in cosmic scale, where space itself grows, the light still keeps to its rule. We do not measure the speed of galaxies by their engines. We measure it by how space unfolds. And sometimes, unfolding happens faster than light can keep up. But even then, the rule holds, because light isn't slow, it's constant, and constancy is what makes the rhythm of the universe legible. You turn in this dream, gazing at the sky of long-faded stars. Some light will arrive tomorrow, some will never arrive, some already did long ago, and now echoes only in memory. But the message is the same. The universe expands, light travels, and time, even stretched thin across eternity, still listens to the same steady beat. You feel small now, but not insignificant. You are part of the tempo, a witness to its grace. And even if some stars have moved beyond your reach, the light they left for you is still arriving, right on time. You open your eyes and now, everything is red. Not a harsh red, not fire, but the faint warm glow of something impossibly old. This is not a light you can see with your eyes, but it is there, all around you, invisible, constant, gentle. It is the cosmic microwave background, the first light ever released into the universe, and it's still here, still moving, still arriving. You're floating now, not in space, but in time, back, far back, to nearly the beginning. The universe was once hot, dense, blinding. So much energy packed into so little space that light couldn't travel at all. Photons bounced endlessly between particles, unable to escape, like echoes trapped inside a cave. And then, everything cooled. The universe became transparent, and suddenly, for the first time ever, light was free. This first free light, the relic radiation of the Big Bang, has been moving ever since. More than 13 billion years of steady, uninterrupted travel. Not from a single point, from everywhere. The sleepy physicist once whispered in class, "We are still bathing in the afterglow of creation." And it's true, the photons that form this background are everywhere. Passing through you now, they've cooled, stretched, slowed in wavelength, not in speed, because light speed never changes, but space does, and so the light stretches with it, from blinding white to gentle microwave hum. You can't hear it. But in 1964, 2 engineers accidentally did. They thought it was noise from a pigeon's nest, but it was the oldest message in the universe, the sound of time beginning to move forward, the first visible breath of the cosmos. You float now through that breath. Each photon of the cosmic background left its birthplace long before galaxies formed, before stars, before planets, and yet it's still here, still arriving, touching every part of space with equal patience. It reminds you of a truth deeper than words. Light is memory, and the oldest memories are the slowest to fade. That's why this background isn't just radiation, it's a boundary, a wall past which no light can reach us, not because it never existed, but because it never had a chance to escape. Beyond that wall, everything is unknowable, not hidden, just unreachable by light. And so, the cosmic microwave background is our cosmic horizon, our earliest photograph, the first frame in the movie of everything. It does not flicker, it does not change, it simply is. You lie back in its warmth, invisible, ancient, unbroken. Every second these ancient photons pass through your body, not dangerous, just present. The speed of light has brought them to you after an unimaginable journey, not rushed, not delayed, but perfectly paced. They remind us that we're not separate from the beginning, we're woven into its light, and that the light itself, though old, though quiet, is still speaking. It speaks with the voice of speed, the voice of constancy, the voice of memory without end. Now the light bends, not like a branch in the wind or a reed in water, but like a path being persuaded by something it cannot see. You're near a massive body, a star maybe, or something far stranger, and the light that once travelled straight curves. This is gravity's whisper. You've arrived at the edge of Einstein's deeper dream, not the special theory that played with speed and time, but the general one where mass bends space and space tells light where to go. Here, light still moves at its constant speed, but the path it takes is no longer straight, because straight lines no longer exist. You're no longer in empty space. You're in curved space, space shaped by the presence of mass, like fabric pulled by a weight, and light, massless, unyielding, obedient, follows that curve. Imagine this now, a beam of starlight skimming past a sun. It bends, not because it slows, not because it's pulled, but because the very space it travels through has been reshaped. This bending has been seen, measured, confirmed. During a solar eclipse in 1919, starlight appeared displaced, moved slightly from where it should have been, because it had curved past the sun's invisible warping. The sleepy physicist once drew it as a river flowing past a hill. The water doesn't curve because of force, it curves because the ground beneath it is not flat. You feel it now, the sensation that light is both free and not, always moving, yes, but along paths carved by gravity's invisible hand. This is how we understand gravitational lensing. Galaxies behind galaxies, light wrapped and doubled, stretched into arcs and rings, not because the light changed, but because space-time did. You see it now like folds in silk, massive objects bending the weave of the cosmos. Photons obey the fabric, even when the fabric is twisted. You realize something here. Light never rebels, it simply adapts. Even when gravity leans hard, light finds the new path and takes it. No resistance, no hesitation. But the deeper truth is stranger still, because gravity doesn't just bend light's path, it also slows down time. You're now near a dense planet. Your clock ticks, and above you, far from gravity's grip, another clock ticks faster. This is gravitational time dilation. To light, moving at its speed, time stands still. But to us, measured, massive, rooted, time flows differently depending on where we are in the fabric. The physicist once wrote, "Gravity and light are not enemies. They're old partners, negotiating the structure of reality. You believe it now. You feel it. You watch a beam of light curve around a black hole, not fall into it, not flee from it, just curve, obeying a rule deeper than speed, obeying the shape of space itself, and that shape was carved by mass, was deepened by time, was made visible by light. This is why light matters, because it doesn't just illuminate the universe, it maps its structure. When light bends, we see the shape of gravity. When light stretches, we feel the breadth of space expanding. When light delays, we glimpse the folds of time itself. You sit quietly now, watching a single ray of light trace the curve of an invisible field. It arcs, gently, like a brushstroke across the sky, not resisting, not questioning, only honouring the form beneath its feet. And that form is gravity. It does not slow the light. It does not steal its speed. It merely reshapes the road it runs. And in that quiet reshaping, we learn the most beautiful truth. Even the fastest thing in the universe must follow the curves of the slowest. There is no sound here, no time, only stillness, deep and infinite. You're standing at the edge of a black hole. The stars above you still shine, but the light near this place, this gravity well beyond imagining, behaves differently. It stretches, slows, fades. This is the event horizon, the boundary between what can leave and what can never return. To you, light still moves at its unchanging speed, but to an outside observer, far from this abyss, it appears to slow, fainter, redder, frozen at the edge. This is not illusion. This is space-time pushed to its limit. Because here, time no longer behaves like time. It flattens, it stretches out into eternity. And for light, which normally travels without effort, this place is the final test. The sleepy physicist once wrote, "A photon hovering at the horizon is both moving and not. For it, time has stopped, and yet it remains." You float closer. You see a beam of light emitted just above the event horizon. It moves upward, slowly, agonizingly. To you, it still travels at the speed of light, but the climb is harder, as if the very slope of reality is steep. The closer the light is to the horizon, the longer it takes to escape, until eventually it doesn't. It hovers, not in motionlessness, but in eternal delay, its signal never reaching the outside, and if you were to fall in, you would cross the horizon without feeling it. No sudden jolt, no flash of warning, only motion continuing, but inward forever. From outside, no one would see you fall. They would see you pause, hang like a ghost, and then fade away, because the light reflecting off your body would slow, stretch, and finally vanish into darkness. And yet, from your point of view, nothing strange has happened. You fall, you move, you feel, until you no longer exist as the world once knew you. This is the power of light's final test. It shows us where the rules begin to buckle, not break, but surrender to a higher curvature. The speed of light still holds, even here, but it reveals the edge of the possible. You lie down now near the horizon, as if resting on the hem of time's final curtain. You look up at the sky. From here, the stars seem to accelerate, as though time out there is rushing ahead, leaving you behind, and in a way, it is. Because gravity here has slowed your clock to near nothing. The universe above you races on. Galaxies spin, civilizations rise and fall, light moves, but you remain. You become a pause, a delay, a quiet echo at the boundary between light and the unknown. And yet, the speed of light still defines everything. It tells us what can escape, what can be seen, what can be known. Beyond the event horizon, even light cannot leave. And if light cannot leave, then neither can information, then neither can presence, then neither can past. So this place becomes silence, but not emptiness, because light was here, and where light has once been, something remains. Even if we cannot see it, even if the message never returns, the limit holds, the wall stands, not of stone, but of speed, and on the edge of that wall you sleep. And now we rest. The journey is complete. 18 quiet steps through the rhythm of the universe, each one lit by the same guiding beam. Not a beam that blinds, but one that whispers softly, gently, always forward. You're floating again, weightless, massless, if only in feeling. You drift through the space between thought and silence, carried not by speed, but by stillness. Around you, nothing rushes, not even light, because here, at the end, there is nowhere left to go, only a widening quiet. The sleepy physicist has closed their notebook. The tea has cooled, the chalkboard has faded, but the ideas, the slow, steady questions, remain, echoing like starlight long after the star has gone dark. You breathe in and feel time as it stretches just slightly to hold you. No cause, no effect, just being. The laws remain, the limits stay. But in this soft hour, you're not here to test them. You're here to rest beneath them. As the last thoughts dissolve, of clocks and photons, of bending space and layered time, you find yourself folded gently in the curve of sleep, the shape of gravity's cradle, lit faintly by the memory of a beam that never stopped moving. And neither did you. You're safe in the dark, not because there is no light, but because the light is resting too. Let it drift. Let the last wave stretch. Let every question go unanswered. You're not chasing the speed of light tonight. You're becoming still enough to listen to it,